So with this problem, we have a block that has a mass of 5.1 kilograms, and it's pulled up an incline of 24 degrees with a force of magnitude 38 newtons. I left off the vector sign on the force because it told me that this is the magnitude. It doesn't include the directionality. And then this wants us to find the acceleration of the block if there is no friction, and also to find the acceleration of the block if there is kinetic friction of 0.12. So I know that this is a forces problem. I also know that there is friction here. So I need to list off force is equal to mass times acceleration. This is Newton's second. I need my equal and opposite forces, Newton's third, and then I'm also going to include the equation for kinetic friction here. So once I have this listed, right, I need to draw my force diagram. So I'm just going to scroll past the problem statement so that I can focus on just drawing my force diagram and all the information that I have, right? So I'm going to redraw my inclined plane. I have theta here. I have a block of mass m, and it is being pulled up this incline with an applied force of 38 newtons. So the next thing that I need to do in the situation where I have no friction is I need to draw out the forces that are acting on this block. So I know that I have my force of gravity and I have my normal force that is perpendicular to the surface. I then need to break my force of gravity down into my force of gravity in the y direction and my force of gravity in the x direction, noting that this angle is the same as the angle of the incline. So once I have my force diagram drawn, I can go ahead and set up my equations of motion here. Remember, I need to do my x direction and my y direction separately from each other. So I have the summation of forces in the x direction, which will be my applied force and also my force of gravity in the x direction. I'm going to want to determine the acceleration, meaning that this block has to be in motion. So I have the mass of the block times the acceleration in the x direction. The next thing I want to do is I want to incorporate the directionality here. So in this situation, based off how we drew this picture, we have that our applied force is going in the positive x direction and our force of gravity in the x direction is going in the negative x direction. I'm not really sure whether this block is going to be moving up the incline or down the incline. It will depend on how large my force of gravity is. I assume it's going to be moving up the incline, but I need to make a note here to check my direction later. The next thing I want to do is I want to replace the force of gravity in the x direction with either the sine or the cosine aspect of it. Remember, if I draw this triangle out and I do SOHCAHTOA, I can determine whether it is sine or cosine. I have already done that. So I will replace my force of gravity in the x direction with mg sine of theta, and this will be equal to max. The next thing that I'll want to do is determine whether or not I need to even consider the summation of forces in the y direction. Because this applied force is going directly in the x direction, it's not going to produce any acceleration in the y direction, right? So if I take this block and I just pull it up the incline in my x direction, there's not going to be any up or down motion in the y direction, so I know that this is going to be equal to 0, right? Because it's not going to levitate off of my inclined plane, and it's not going to sink down into my incline plane. That means that to solve part A, I just need to rearrange this equation here. I'll call this equation 1 to solve for my acceleration. So I'm now going to rearrange this to try to get the acceleration by itself. I'm going to drop off the sub x because since there's no acceleration in the y direction, the acceleration in the x direction is the total acceleration of this object. And this is going to be equal to f minus mg sine of theta divided by the mass of my block. So I'm now going to plug in my numbers, 38 minus, my mass was what? 5.1 times 9.81. This is positive because I already took the directionality out of this. Sine of 24 degrees divided by 5.1. At this point in time, I'm going to see if the force applied is greater than the force of gravity in the x direction, meaning that my block will move up the inclined plane, or if it is less, meaning that my block would move down the inclined plane. To do this, I'm going to see if A or B is larger. So A is 38, B is 20.4. So because A is greater than B, because my applied force is greater than my force of gravity in the x direction, we know that the block is going to move up the inclined plane, thus having a positive acceleration makes sense. So my acceleration is going to be 38 minus 20.4 divided by 5.1, and I get that my acceleration for this block, if there is no friction acting on the block, is going to be 3.46 meters per second squared. And this is my solution to part A. Part B, I'm going to draw a line. Part B wanted us to find the acceleration of the block. So we want acceleration again, but now we have a coefficient of kinetic friction between the block and the incline of 0.12. So I'm still going to solve for acceleration, but I need to redraw my force diagram because I have an additional force here. Now I have the force of gravity. So I have my inclined plane, I have theta, I have my block of some mass. I still have my force of gravity going down, my normal force perpendicular to the surface of the inclined plane. I have my applied force of 38 newtons. I need to break this down to the force of gravity in the y direction, the force of gravity in the x direction, and now I need to determine where and what direction to put my kinetic frictional force. Well, in the last problem, we determined that this block is going to be moving up the inclined plane if there is no friction. Because friction opposes relative motion, and the relative motion is up the inclined plane, my force of friction is going to be moving down the inclined plane. So it will be going in the same direction as the force of gravity in the x direction. So now I need to create my summation of forces in the x direction. I'll have my applied force plus my force of gravity in the x direction, and now I have this frictional force. I know that this has to be moving because I have kinetic friction, and kinetic friction tells me that it's moving. I can then replace these forces with their more specific descriptions, right? So I have my force applied. I'm going to include directionality here. So I have minus mg sine theta. And I have minus mu sub k, my coefficient of kinetic friction, times the normal force. And this will be equal to mass times acceleration in the x direction. The next thing I want to do is I want to think about the summation of forces in the y direction. Keep in mind that now that I have normal force in my x direction, I have to include the summation of forces in the y direction, because this is where I'm going to figure out what my normal force is. I'm setting this equal to 0 because I'm also still assuming it is not going to levitate off the inclined plane or sink into the inclined plane. This means that I will have my normal force minus the force of gravity in the y direction equal to 0. I can now replace this with mg cosine of theta, and I find that my normal force is mg cosine of theta. I can now plug this mg cosine of theta into my summation of forces in the x direction. So this will become the applied force minus mg sine theta minus mu sub k mg cosine of theta is equal to mass times acceleration. I got rid of the sub x because I now know that all of the acceleration that's acting on this block is going to be the x component, so I'm just going to call it acceleration now. This is the same situation. I need to solve this for acceleration. So I can have acceleration is equal to the force that's applied minus, I'm going to group these together, mg sine of theta minus mu sub k cosine of theta. All I did here was I pulled out the mg's because they're shared together. That would make this a plus because I have the minus, and the minus would distribute into this. And this will be divided by mass. I'm now going to plug in my values, right? So I had 38 minus 5.1 times 9.81 times sine of 24 plus 0.12 cosine of 24, close my bracket, divided by 5.1. I'm not going to punch this all in the calculator at one time because I know that I am more likely to make a mistake if I try to plug everything in at once. So the 5.1 times the 9.81 becomes 50.03 times sine of 24 plus 0.12 cosine of 24 is 0.516. This will all be divided by 5.1, and I will get 38 minus 50.03 times 0.516 is 12.81 divided by 5.1, and my acceleration is going to be 2.39 meters per second squared. And this is the solution if I have kinetic friction. So it's still going to be moving up the incline in the positive direction, but when we add this coefficient of kinetic friction, when we add kinetic friction to the system, we see that if we compare 1 and 2, the kinetic friction has slowed down the acceleration of this object.